So in our last episode, we learned the basics of math, but for today's lesson, we're going to take that to the next level. Hi there, I'm Roy, and welcome to My Code Corner, where we take a hands-on approach to topics in computer science. In today's episode, as you can see on the screen, we are going to go into Boolean operations. Now, Boolean operations happens to be one of those key things, much like types, and while very simple to learn, mastering this one is vital for your journey into computer science. So let's go ahead and jump into the compiler. But before you do, go ahead and take the time. If you haven't done it already, hit that subscribe button. It does help the channel, and it actually will let you know what we're going to get into. So let's get into it. And of course, back to our beginnings. And we're going to talk about, well, before we start, let me talk about what Boolean operations are. As we remember back in the types episode, a Boolean actually held one of two values, either a true or a false. Matter of fact, if I go ahead and cout, just to show you, simple cout true. That's all we're going to do. If I hit run, let's see what it does. Of course, it doesn't specify true, but what it does is 1, because we know 1 is kind of like a light. 1 would be on, false would be off, or 0. And to prove that, we'll go ahead and reset, hit play, and we see false is 0. So that's it. That's going to be the basics of what we're going to do. Now, I wanted to focus on this one today simply because my feeling was whenever I started, I actually planned and shot in episode 5, and I was going to do flow controls and Boolean operations. And just a hint, that's what the next lesson is going to be. But after I was done and realized I had shot for an hour and a half, I realized two things. One, nobody's going to sit there and listen to a lesson that's basically equivalent of a full-length movie just on flow control and Boolean operations. And two, I was not giving it enough emphasis because Boolean operations are extremely important. As you'll find, these will be scattered throughout a lot of the different parts as you, not only in C++, but any computer language. But we are going to go ahead and create ourselves couple variables, making them very, very descriptive. All right. And of course, just to prove, as we mentioned before, a variable is just a bucket that holds a value. And since these are both Booleans, if I say is true, that's going to return a 1. And if this one works, I'm not going to do the other one because we know it's just going to work. And it does. There's our 1. Now, when it comes to Boolean operations, there is actually only a handful of those. There is equality, inequality, not, less than, greater than, less than, equal to, greater than, equal to, and then we'll talk and or. That's it. But just with those very few operations, you can actually get into some very, very interesting combinations. And again, I want you to understand this one. That's why I wanted to pull this one out very specific, because you need to know this one. This, again, this is kind of the make or break in computer. This is the logical piece. This is the part that's going to open all the doors when it comes to computer science. All right, let's go ahead and start. And I did mention, well, let's go ahead and start with not. So the not operation is simply that. A not will make a true a false and a false a true. And a not is simply an exclamation point, or a bang is what we like to call this. So if I say, I'm going to go ahead and not put that there. I'm going to put this down here. If I say bang, I'm going to put is true in parentheses. I don't have to. I can have this just together. I'm just doing this to kind of call it out a little bit. But if I hit this not is true, and the reason why we call it not is because it's easier to read this way, this should return false. And it does. There's our 0. And of course, not false, you can string these operations together. So what about not is false? What would that be? So if I do bang bang is false, or not is false, this should be false, which it is, 0. Because if you think about it, is false is false. The first not will make it true. The second not will make it false. So not cancels each other out. That being said, if I did not, this would be true. And yes, you can continue this on and on and on. And of course, this is kind of a dumb example, but understand that just showing you that you can string a lot of these Boolean operations together to get the answer you're looking for. Again, you're only looking to be a true or a false. So that's the not. And not becomes very important, not just for cases like this. There, as we, again, once we go into flow controls and loops and other topics like that, I will call this out. So I just wanted you to get the understanding of this is Boolean operations. This is Boolean math. Results in one of two values, a true or a false. Now the second thing I want to talk about is equality. So equality is simply two equals. Now this one, let's say if I say if false equals false, which would be basically if false equals false, this should be true. Because false equals false is true, right? So if I hit run here, it's not actually going with this variable here. It's simply the variable that we're going to do the check against. It has nothing to do with what it's going to print out except because it's equal false. So I hit run here. This one should result as true. And if I say equals true, this one will return false. And now you're understanding why I'm doing this very specific, because these operations can get honestly a little bit tricky, especially as we start stringing these together more and more and more. So that's equality. Very, very common mistake, especially I want to say as newer programmers, but really any programmers in C++, because I've done this myself at times. Notice that it is two equals. If you say is false equals true, one equals is assignment, two equals is equality. So is false equals true. If I hit play on this, now it's going to say true, but that's not right, correct? It isn't. But what happens is when you do assignment, what it returns back is the value that you're putting into that variable. To show what this means, if I do just cout is false, because remember this is just a Boolean, we set is false up here. This is just a Boolean variable. Just because it says in false doesn't mean anything. That's just what I named it. But after this statement here, after this command, if I hit run, I should see this one will come up as true, as we saw here. But what's going to happen here? That's also going to return true. Now the variable that says is false has a true value in it. So again, very, very easy mistake is one equals instead of two when you're wanting to do equality. That one equals means you're assigning it. And of course, in this case, we did get a return back that said true, but we know that true was not in here before. It's just the return value back when we did that assignment. We'll talk about return values when we get into functions. Again, why you want to become part of the channel. But let's go ahead and back this out. And I'm going to do something a little bit different. I'm going to do int a equals 0, b equals 1, c equals -1. And I'm doing this for a reason. While we're showing this here, imagine this equality here, we're doing it with a Boolean variable. Understand that you do not have to do a Boolean variable here. The return of this Boolean operation will be a Boolean, but it doesn't mean that you can only use Boolean variables. I can do something like this integer variable, a equals true. Well, first off, what will happen here if I hit run here? It actually tells me I have an unsafe mix of type int and type Boolean. Actually, let me go ahead and you see it's a 0 here, but show you down here. My output window's on a different screen. That's why sometimes I'll say something and I'm not showing you. But you notice we get one of those warnings because we mixed two types. And remember that when it comes to integers, a 0 can be a false, a 1 can be a true. Now, if I did something like c equals true, and that's going to be false, definitely, because it's not going to be anything here. which is false. But if I set b equals true, because of that conversion, this will actually return true, which it did. Next thing, and when it comes to equality, it could actually be two variables comparing them. So in this case, b equals a. I'm going to print out the Boolean comparison here, the equality. Does b equal a? And we all know that is false, so this one should return 0. And if how about did b equals b, which is kind of pointless because of course it's going to equal itself, but this one should return true, and that's true. So again, equality is simple if whatever's on the left is equal to whatever's on the right. This can be true for, let's say b plus c. So 1 plus a negative 1, which will be 0. Does that equal a? Knowing this math, that would be true, and it is. Or if I said about b plus c, which would be 0, equals a times 100. Of course, multiplying anything by 0 is going to be 0, so this one should also be true. And you can build up, of course it is, you can build up these equations. And this is actually where the strength, this is where a lot of the controls go into. Understanding that all you're looking for is what's inside here is either going to equal a true or a false. So that's equality. Again, what on each side, you can get very, very creative with this one, but realize is that whatever it is, it's basically testing, are they equal or not? If they're equal, it returns a 1. If they're not, it returns a 0, or a true or a false. Now we got the next one. So we've done equality. Now what's the inverse of that? Of course, that would be inequality. And that one is actually really, really simple too. As I mentioned before, if I put a exclamation point in front of something, it turns it into it's a not. It reverses what it is. And matter of fact, if I could put a not right here, and it would, whatever this returns, which would be true, it would actually reverse it, which would be false, proving it. There it is. But I could also say, well, I know this equals this is true because I've got this equality, so it's going to return a true. But to do inequality, all I do is take that first equal sign, basically put exclamation. Actually, let me show you what I'm doing. I'm doing exclamation point, no space because I'm going to tell you what's happening over here on the side, equal. So it'd be exclamation point equal, or bang equal. But if you noticed, it put, and you've probably seen this in books and whatnot, when you see the equals with the slash to it, which means not equals. And I'm going to prove that this is going to work before I tell you about this specific thing that's new in Visual Studio 2026. So b plus c is 0, does not equal 0 times 100. This will return a false. So hit run, and it's false. But interesting thing is this character. If you notice that whenever I did type exclamation point equals, it turns it into this. Matter of fact, if I remove this space, it turns it into that. This is known as a ligature font. Ligature fonts is something that kind of makes it easier to read when you're not used to it. There's a lot of things that a ligature font will do, changing some of the font sizes and whatnot. It's there to get more code on the screen and to make it a little bit easier to read. Now, if this is something you do not want, there is a way to turn this off. If you go into Tools, Options, wait for my settings to come up, go ahead and we're going to search for fonts. And you're going to get these more settings. More settings, this is changing as 2026 matures. These are things that they're trying to convert into this new settings piece. Anytime you see these callouts like this, it means they haven't integrated it in yet. So right now, as of January 29th, 2026, we don't know when they're going to fix this. Right now, this is where it is. But I'll go ahead and open up fonts and colors. And if you're used to writing in Word or whatnot, you're used to seeing this type of font box. You can, there's this Cascadia Code Light. That is a ligature font. You can change it into something like Cascadia Mono. And if I do that and then go hit OK and go back here, You notice there's my bang equal. It changed every single one of them. Personally, I like the new way better. It reads easier. Even though I've coded for years and I'm so used to seeing this, especially for new developers, understanding how that reads makes a little bit more sense. I'm gonna go ahead and set that back. Again, it's not Cascadia Mono, it would be Cascadia Code Light. And there's a lot of ligature fonts, and you can Google that. This is just the default one that they use, Visual Studio uses, and there's that not equal sign. So that's inequality. It's the opposite of equality. If I said true does not equal false, you see, showing you can still do this with literals too. Take all that away. This will also return true, and it does. And so think about it. This, again, as long as you know equals equals is equality. So if whatever's on the left is equal to whatever's right, it's going to return true. Otherwise, it returns false. Inequality, if whatever's on the left does not equal whatever's on the right, it will return true. Otherwise, it will return false. That's the basic Boolean operations. And that's the ones that we can actually use for these. The next ones we're going to do is let's start with less than. So in this case, we know that a is 0. A is less than, well, we've seen this and we've done math before. A is less than B. What do we think that's going to be? Of course, it is just your basic less than sign. This should be true. And it is. And actually, let me comment this one out so we don't keep confusing ourselves. And I commented out that one. Again, different window. So we should just have the 1, 1. And if we said A is less than C, since C is -1, we know that's false. That should return 0. And it's true. I'm sorry, it's false. I'm going to have to start remembering when I say true, it means what I saw is true, but I need to start reading that as every time I say a 0, that's false. I can say, what about making this one a numeric literal? That would be a number. So A is less than 1,000. That would be a 1, true. Correct. And A is less than -1,000. Also, well, that one's false because it isn't. Now, when we were doing math, when we were doing math, one of the things with assignments was everything goes to the left. That was where the remainder went to. Let me show you in these Boolean operations, because there is no assignment here. So if I say -1,000 is less than A, can I do this? Actually, I can. It's kind of like when you're doing the formula on the right side of an assignment. It doesn't matter what order you put these. It only matters that what the result's going to be. So in this case would be 1, which would be true because -1,000 is less than A. We can, of course, do math. We can do actually quite complex mathematical calculations. We're not going to here, but we'll do A plus B. That will be 1. Is 1 greater than -1,000? That should also be true. That is true. And let's go ahead and we'll surround this one. And I'm going to say -50 times. Of course, when you're usually writing math, you will just, you would not put that multiplication here. Unfortunately, with computers, it doesn't realize that if I just did -50 in front of a plus B, that doesn't mean it's a multiplication. You have to spell it out. But in this case, it would be A plus B, which would 1 times -50. Is -50 greater than -1,000? Well, actually, that would still be true. And realize that it actually is going to evaluate this entire side before it actually checks the Boolean operation. That's less than. I can do greater than, which is the opposite. This one should be false. And that's correct. I'm going to start using correct and incorrect from this point on. I could, reverse this one here and say, remove this. Is this greater than -1,000? And that would be true. That's correct. So as you see, you can build quite complex as long as, whatever's on the left gets evaluated. Whatever's on the right gets evaluated. It does that Boolean operation at the end. Is it true? Is it false? So we've now done less than, we've done greater than, we've done equality, we've done inequality, we've done not. We can also do A is greater than equal to. Now, again, this is that lenticular font. Once again, this would be a greater sign and then equal sign. And of course, it turns it into that thing that we've usually seen in our math books. But A is greater than or equal to, we'll say 50. And since A is 0, we know that's going to be false. And if I hit run, and it is false, that is correct. If I said negative 50, this will be true, also correct. And if I said 0, because before, actually, let's go ahead and copy this. I'm going to go ahead and comment out the first one. But if I just said A is greater than 0, this will be false. But since A is 0, this one will be true. And that's correct. Again, same rules apply. We can do very complex mathematical calculations on both sides. Also, I mean, right here I'm using ints just because ints are nice and easy. You can use short, int, longs, long, longs. You can actually compare. There will be implicit typecasting if you would say do an int to a short, because in that case it's just doing the compares. If actually, let me show you one of those. If I did a short x equals 5, is A less than or equal to, actually, let's say if x is greater than or equal to A. In this case, it will be true. Hit play. Go ahead and fix my error since I removed I didn't add the semicolon. Very important thing is make sure you put semicolons. There's a lot of languages like Python, Swift, two of the other languages are going to do that. That's not necessary. But in C++, a semicolon tells the end of a command. So when you bounce in between languages, this is a very common mistake, which I just made. So let me go ahead and hit. Now it did a explicit cast. And x, which is 5, is greater than or equal to A, which this came up as true. Even though these are two different types, they're the same numerical type, but they are two different types. So what about if I did a float 10.5f? Is 5 greater than or equal to, make sure I set a variable name, is x greater than y? In this case, 5 should not be greater than or equal to a float of 10.5, but if I hit play, what happens? It's correct, because 5 is not greater or equal to a 10.5. But if you notice, there was no talk about potential loss of data. It's just doing a compare. There will be times that you cannot compare two variables. When we start getting into things like classes and structs and other things, you're going to have to write your own Boolean operations. And that will be many, many sessions in the future. But know that it will be times that you might have to actually build your own. All right, so we've done equality, inequality, not, less than, greater than, less than, equal to, greater than, equal to. What else do we have? Well, from a basic Boolean operations, that's it. But wait, there is more. It's possible that you can string along multiple Boolean operations. If you've ever done any sort of logic puzzles or logic exercises, you will hear of two other terms. You will hear of 4. 2 of those we really can't do without doing some funky maneuvering, which we may cover in a future session, not tonight. But you will hear of and or. Exclusive and exclusive or XOR, XAND, there is no Boolean operations raw in C++. Again, you have to do lining up, combining a few of these things to actually have that occur. But there is an and there is an or. Now, what do I mean by and or? Well, when it comes to and, it actually is one of if I have two Booleans, the AND tells me how I can combine them. For example, if I have a true and a true, that equals true. If I have a true and a false, that equals false. If I have a false and a false, that equals false. And of course, if I have a false and a true, that equals false. So basically, I have to have two trues in order for this to become a true. Well, there is a Boolean operation for this also. So let's go ahead and show you what that one is. And I'm going to comment this one out, but I am going to steal it. So in this case, I'm going to surround it by another set of parentheses because, and I do this. This is actually part of the common things I do because I like to keep things grouped together. So when you're kind of skimming through code, you know that they're logically together. You don't necessarily have to, but there is cases that you do. Matter of fact, in this case, we would have to, but try to group your pieces together just for readability. Remember, readability is very, very important. But we have I'm going to say a equals 0. Of course, put my two equals there. So I know this one is going to be, let's see, y is greater than x, that's going to be a false, and a is greater than 0, that's going to be a true. This will return, if I AND these two together, this will return a false. Now, what's the AND sign? What's the AND operator? Actually, once again, it's very easy. And the fact that a lot of these Boolean operators, it's always two of something, except for less than or equals, or less than or greater than. Well, the first one would be, for an AND, we have two ampersands, or Shift 7 on my QWERTY keyboard. In this case, it says this is a false, and this is a true. So if I have a false and true, it should equal false. And if I hit run, that's correct. If I turn this, actually, let's turn this one around. Actually, I'm just going to do less keys and no lenticular fonts. So in this case, this would be true, and this would be true. This should return true. That's correct. How about x is less than y and a does not equal 0? And if I hit run on this one, that should be a false. That's correct. And of course, what is x again? X is 5. X is less than 0. And I hit run, and that will also be false. And we just did all four cases here. Now, if you noticed, I had an X, I had a Y, and I had an A, and I had a numeric literal. You can combine all the pieces. Again, all you're doing is checking for Booleans. You're doing Boolean operations on values. It doesn't matter if you're mixing them up. It actually even doesn't matter if I say, what about instead of A does not equal 0, I say A is true and X is greater than 0. So this is a true and this is a true. Therefore, this should be a true. Hit run, and it is. So you can mix these up. And this is actually where the power of Boolean operations occur. When you start figuring out getting the flow through your system, knowing which path your code is going to take, this is when you're going to start stringing these together. This is that part that, again, get used to these Booleans. Start coding them, writing it out, making sure that what you think it's going to be is what it becomes. As every time I would hit run, I would say if it was going to be true or false, because I know already what this means. When you start writing some very complex programs, where they get complex is these Boolean values may be 4, 5, 6 pieces deep, potentially more. I mean, you can write some very, very complicated Boolean operations, and it can get quite complex. So again, get familiar with this. The other one thing I did want to point out, and it's an optimization trick. One optimization that I use a lot is that whenever I string together my Boolean equation here, I make sure that that first evaluation I do is the one that's most likely to become false. The reason being, the way the runtime works is that if it detects this x is greater than 0, let's do x is less than 0, I know this is going to be false. This part's false, this part's true, even though I ended them together. Since this one evaluates to false when the runtime performs its comparison, it knows this is false. Therefore, it doesn't even evaluate anything here. So if you have a bunch of ands, or ands and ors, as we'll show ors in a second, if you have a bunch of ands and ors here, since this one's false, it knows it doesn't have to evaluate anymore. It is definitely a speed up. The speed up may be nanoseconds, but honestly, when you're really crunching some of the code that I've done that had to be extremely optimized, little things like this do add up. Enough nanoseconds is a millisecond. Enough milliseconds becomes a second. That is real time when you're talking about real time computer systems. So that's and. Now let's talk about or. And I'm going to copy this because I love copying code and making it work a little faster. And of course, fix all by tabbing. And we have or. So in this case, true would be true. True or false would actually be true because all it has to be is one of them. False or false is false. And false or true would be true. To show you the or operator, comment this one out again so we don't confuse our results. Instead of and, or ampersand for and, for or, it's two of we'll say the pipe characters. This is that straight line. I call it pipe because that's what you use when you're kind of sending things in Unix. It is actually the character when you hit shift slash. It's that character. There's your slash, there's your or. So pipe is what I call it. That's your or. So in this case, we know that x is less than 5, or x is 5. Is 5 less than 0? Well, that's false. Or true. This will result in true. That's correct. If I would say this or false, so in this case it's false or false, this will return false. Let's do x is greater than 0. We know this is true, so we have true or false. This should return true. And that's correct. And then finally, x is greater than 0, which is true, or true. This will return true. That's it. That's it when it comes to Boolean operations. Very, very few operations here, but I'll tell you that these operations you can build some very, very complex systems with. And we will use this quite a bit. This is one of those key pieces. This is how you determine logic in programming. These type of Boolean operations are in all computer languages. They may be slightly different depending on the language, but they are all there. So understanding Boolean operations, even if the syntax is a little bit different, understanding Boolean operations is a key part of learning how to develop. So I would suggest to practice. This is one of those things. Honestly, this is more practice than a lot of the other pieces like math, because this one, once you have this, it makes even reading code easier. So that's it. Let's go ahead and talk about what we just covered. So, Boolean operations. Again, there were only, how many was this? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have the not. We have equality. Remember, it's 2 equals not 1. 1 would be assignment. 1 is a great way of having mistakes in your code. I've seen that occur many times. I've actually had it done myself many times. A not equals, it's that bang equal. You have less than, you have greater than. You have less than equals, you have greater than equals. Notice that on all three of these, the equals is actually always at the end, not at the beginning. And then you have the two that you can string together. You have the ands and the ors. If you want exclusive and, exclusive or, you would actually use the nots or the not equals, and you'd start putting them together. Again, we'll cover that at another time when we actually have to use that. but understand that it's not native. It's it's not a core operator, but there is ways to get through it. But that's it. Boolean operations, very, very important. Why I wanted to call this one out specifically, not group it with flow control, which will be our next session. You are now starting to get into the point of writing code. Now, it's still not very heavy. Once we get to the next section, it will start feeling like you're writing a computer program. Right now, what we're kind of doing is just kind of experimenting to understand what the values are. But we are about ready to move into the next one. So definitely you want to make sure you're part of the community. Go ahead and hit subscribe. Hit that like button. I do appreciate that. And of course, hit that notify. I'm trying to put these up more often. I do have a lot of lessons actually already planned and well in advance. I just got to sit down and shoot the video. So I appreciate you coming on this journey with me. And until next time, keep coding.